Hi, in this video we are going to discuss one of the most important technique, that is confidence interval in the data science. Let's start with what is the use of this confidence interval. We will call as CI in simple. The first thing, in the most of the cases we are find the approximate values, okay, from the statistics. To make simpler, it's a point value we will give. Instead of giving the point value, it is good to give the a range of value. That will make more sense about the data or the value. For example, suppose if you want to give the mean height of Indian people, to find the mean height of Indian people, we are using the central limit theorem. By the central limit theorem, we will get some mean value x bar. This is a approximate value. For suppose we will get like 165 value we got from the central limit theorem. This is a approximate value because of that. To avoid some problems, we will give the some confidence interval. First we will give like I have 95% of confidence the value of mean lies between 160 and 170. If we give the range of lies this bit, we will get more sense about the data. Now let us see how can we calculate this confidence interval. For suppose I want to find the confidence 95% confidence interval of mean. How we can calculate 95% of any distribution? Let's consider D. Okay. In the case 1, let's consider two cases. If you know the standard deviation of the distribution D, suppose standard deviation, in this approach we are going to use the technique of central limit theorem to find the 95% confidence interval of mean. By the central limit theorem, what we'll do in the central limit theorem, that we will see. We have data, x is the data, it is the distribution D. Now we will take the subset of data sets S1, it contains data points, and S2 it also contains data points. Similarly Sn, it also contains data points. We will find the means for the each subset. We will get the mean for the first subset x1, the mean that we will get for the second subset is x2 bar. Similarly, for the mean that we will get for the Sn is xn bar. And these mean values are in normal distribution that we already know. These are normal distribution. And the mean that we will get by taking the mean of these data points, x bar equal to 1 by n sigma I equal to 1 to n xi bar. This data is like this, normal distribution with x bar as mean, and the standard deviation is the standard deviation of the population data. This is the value, okay, by root n. It represents number of subsets we consider. The more number of subsets we consider, then the mean value is very close to the population mean. Now I want to find the 95% confidence interval of mu. We know one thing from the normal distribution. If the data is a normal distribution with the mean as mu and the standard deviation is sigma. Here 95% of points, data points, lies between mu minus 2 sigma, mu plus 2 sigma. Okay, we observe this thing here. Observe this thing because it is a normal distribution. We got this this 95% of data points lies between these two values. Similarly, this is also in the these points also in normal distribution. This is normal distribution. We have mean mu. Sorry, it is normal distribution, and the mean x bar and the standard deviation sigma by root n. Now we know the 95% of confidence interval data points lies between these two values. Because of it is also normal distribution, we can use this approach. Here the mean is x bar and the standard deviation is sigma by root n. Now replacing those things, x bar minus 2 sigma by root n, this is the lower interval, and the higher interval x bar plus 2 sigma by root n. I have 95% of confidence interval. The mean value lies between these two values. If we know the population data standard deviation, what if we don't know the standard deviation of population data? Let's do case 2. Here we are going to use the t distribution. Let's see first formula, then we are going to tip test. For the t distribution, we have the interval x bar plus or minus t and s by root n. Let us see what are the things here. First, this one. This is the mean that we will get from the central limit theorem. The central limit theorem. By the central limit theorem, we will get the mean mu. Similarly, this is the standard deviation. Okay, standard deviation. For the every subset, we are going to find the standard deviation. This is subset 1 from the data set X and subset 2, and we will consider n number of subsets. For the each subset, we have the means, and by taking the average of the means, we will get the mean for the central limit theorem. Now let us see standard deviation. Similarly, we will find the standard deviation for the subset 1 S1 bar, S2 bar, Sn bar. Here we will take mean of these standard deviations. We will get S bar. This is 1 by n, sigma I equal to 1 to n, Si bar. This is the value that we will get, and the t value now. The t value is based on the confidence, which confidence interval we want to find. If we want a 95% confidence interval, we will get one t value. The value is going to be changed, the t value is going to be changed, and the n value is number of subsets we are considering. By this way, if you want to find the 95% confidence interval of mean x bar minus t by s by root n x bar plus t into s by root n. This is the way to find the mean of the confidence interval if you know the standard deviation of the population data, if you don't know the standard deviation of the population data. Let's see how to find the confidence interval for the median, other things mean. Now let us see how to find the confidence interval for the median or anything like variance, standard deviation. For anything we can find another technique by using the bootstrap approach. Find the confidence 95% confidence interval of data X with a distribution F. Okay, I need to find the confidence interval for the median. Suppose 95% of confidence interval of median. This is the problem statement. Now we have the data X. It's a population data of the distribution F. Now we will take the subset of data S1. The subset of data contains some points. Similarly, S2 also contains some points. Similarly, Sn. Let's consider Sm. Okay. For this subset of points, we want to find the median confidence interval. That's why we will take the median of this subset. We will get M1, M2, MM. Okay. Now we will find this is the medians of the subset values, and M1, M2, MM. Now we will sort these values. We'll get, for suppose if let's take M is 1000, M1 dash, M2 dash, M3 dash, M1000 dash. If you want to find the confidence interval of 95%, okay, here we will take the 2.5 percentile value and then 97.5 percentile value. Here the 2.5 percentile value is M of 25 dash and the 97.5 percentile value is M dash of 975 point. The lower limit, the confidence 95% of confidence interval, 95% of confidence interval of median of the population data X is M dash 25, M dash 975. These two values. This is the bootstrap approach. Bootstrap. Similarly, we can find the confidence interval of the standard deviation. For the standard deviation, we will take, instead of mean, we are find the standard deviation. Okay, sigma. If you want to find the mode, we can use mode M1, M2. If you want to find the variance, anything like that we can find by using the bootstrap approach.